Hi, hello, welcome to Knowledge Center. In this session, I am going to continue the questions which were solved from the previous video. As you all know that in my previous session, I have explained about the solution of a previous year question papers which has been asked in the Kptcl exams. Yes friends, we are solving the previous question papers of Kptcl exams. Now, let us take up the question number 6. Those who have not yet looked into my previous video, go through that. Their first 5 questions have been solved. Now I am going for a next question, that is 6th one. We can read the question from the screen. So here it is very clearly mentioned, a 100-watt bulb is connected in series with a room heater. Full stop. If now 100-watt bulb is replaced by a 40-watt bulb, the heater output will be dash. Okay, so the question is something like this. There is a bulb of 100 watt. Say this is the bulb of 100 watt which is connected in series with the room heater. Say this is room heater. And it is connected across some supply voltage, and that is of voltage is not mentioned here. So definitely it might have connected across some supply voltage. So let us close the circuit. So the voltage is here. Source. Now the question is, as we have a 100 watt bulb, if I change it to 40 watt bulb, what will be effect on the power of this room heater? That's the question. So let us change the marker here. This is bit light. Let me take some other marker here. Yeah, we have it here. See, first of all you should understand the room heater output depends on what parameters. See, heat developed by the room heater can be given as like this, I square R T. Means it depends upon the resistance of that particular heater and at what time the current has been flowed through that and what is the quantity of current. Okay. Say the time, let us say the time and resistance, these two are constant here. Once we design the room heater, resistance will be fixed, and what is the time we are making to flow, that is also say for some particular time seconds. Here current is the major part. Current is the major part. Current can get varied. In this example, this is the parameter which is getting affected, because for 100 watt bulb, I can say, what is this 100 watt bulb now? If its power is 100 watt, we can give the relation of P as V square by R. Whereas you can understand this, we don't know what is the voltage, but instead of 100 watt, now I am making it as 40 watt. The question says that bulb has been replaced to 40 watts. So if I replace it to 40 watt, V square by R, here voltage remains same, the source is not removed or not replaced, this remains same, but power has been reduced. So if power is reduced, you can compare it with the resistance. Resistance will be increased because it is inversely proportional. So the resistance of the bulb is increased. When resistance of the bulb is increased, the current flowing through this is going to be reduced. When this current reduced, these two are in series, so we get the same current in the room heater. So the current in this room heater will be reduced. If this is decreased, the total power of the room heater will be decreased. So among those options, you can select an option B, which is mentioning it as a decreased. Okay, I hope it is very clear. Right. So that is how logically you have to solve the problems. Now let's take up the another question. That question is something. A series resonant circuit implies dash. So there are 4 options provided. So what it is going to be implying as? So series resonant circuit will have some simple parameters. See, we have in series resonant circuit we get Z is equal to R. There will not be having a capacitive resistance and inductives. Okay, we will not have an inductance and a capacitance. We will have only the resistance which is equal to the Z impedance. And at this case, at resonance case, the current is going to be high because there is no capacitive inductance, capacitance and inductive resistance. There is no XC and there is no XL. We have only R. So current will be maximum. Current will be at maximum point. That is one point. And one more thing, they are talking about in option they are given about the current and power factor. So I am pointing about that. Current will be maximum. And what about the power factor? See, if power factor, if Z is equal to R, if you have a resistance in a circuit, then the power factor will be 1. Means the angle between voltage and current will be 0. That this phi is 0. Because when you have a resistance in a resistive circuit, voltage and current both will be in phase. So angle will be 0. So cos 0 is equal to 1. So power factor is 1. So according to this statement, we can say option B, that is unity power factor and maximum current. That will be the answer. Okay. Now let's read another question here. So this is something tricky again. It is about the voltmeter and ammeter. So look at this. If voltmeter is connected like an ammeter in series with a load, what is going to happen? So generally in a circuit lab, in laboratories, you might have designed some circuits and elements will be connected like this. Voltmeter will be always connected across the supply and ammeter will be always connected in series to the load. If you have a load and if you have a supply here, right? So what happens if I connect this voltmeter in series like an ammeter? What happens to that meter? That's the question. So the logic is very simple. Voltmeter is made to measure the voltage, and if you want to get a voltage here, we have a relation like this: V equal to I into R. Okay. So if you want to get a better voltage drop, complete voltage drop here, what we do is we will try to increase the resistance of the meter. So in voltmeter, resistance will be very high. The flow of current will, because of this, the flow of current will be very, very less. Okay. Whereas in ammeter, we need to read amperes, that is current. So the resistance of this ammeter will be very less. Now, if the voltmeter, if I connect it in series, what happens? See, if I connect it in series, you just look into the design. The resistance of the voltmeter will be very high. So if I connect it like this in series, its resistance is very high. So it is opposing the flow of current. So it will not allow the current to flow through like this. So you can read the option B. Almost no current will flow in this circuit. You cannot say 0. Okay. You cannot say it will block completely. It's a maximum resistance will be there. So small amount of current will be flowing. So what happens if I connect voltmeter in series? It will try to block the current. Almost no current will be passing through the load. So that will be the option for this particular question. Hope you are enjoying the explanation. If so, press the like button and also mention your express your feelings through comments. Now let's look into the next question. With rise in temperature, the resistance of pure metals will be dash. So what happens to the resistance with rising temperature? That too in pure metals. So very simple basic concept here. Pure metals, temperature coefficient, that's what the thing you need to understand here. So for pure metals or good conductors, what happens? The temperature coefficient will be positive. And for insulators, the temperature coefficient will be negative. So here they are talking about the pure metals, that is nothing but a conductors. So in conductors, if there is a rising temperature, the resistance will respond positively, means the resistance will increase. So the option A will be the answer for this. Okay, if it is a pure metal, then with the increase in temperature, the resistance will also increase. Okay, now let us go for one more question. That is, a light bulb draws 300 milliamps when the voltage across it is 240 volt. The resistance of the light bulb is dash. So this is very simple and direct question. They have given the current as 300 milliamps. There is a bulb which is having flowing a current of 300 milliamps across the voltage of 240 volt. So what is the resistance? So direct question they are given. Resistance is V by I. Only the thing you have in exam, what happens? You have to solve it without any calculators. That may be the point in some exams. Okay. So just simplification is the funda here. Voltage value divided by 300 into 10 to the power of minus 3, as it is a milli. So if I take it to the numerator, this can be written as 240 into 10 to the power of 3 by 300, which can be rewritten as 240 into 1000 by 300. So 0, 0, 0, 0 get cancelled. Now 3 1s are 3, 8s are 24, 0, 0 we have. So this is 80 into 10, 800. So the resistance will be of 800 ohms. The simple calculation. A direct question has been given. Even this type of questions will be asked in the exam. Only the thing you need to be very careful about the units. Okay. Now let's take some tricky question here. A current of 16 amperes, you can read the question on the screen, divides between two branches in parallel of resistance 8 ohms and 12 ohms respectively. The current in each branch is dash. So it's very clear. First write the circuit. There are two branches. One is of 8 ohm and the other one is of 12 ohm. Both are connected across together, that is parallel. And the current of 16 amperes divides between two branches. So the overall current is of 16 ampere, which is getting divided here. This current divides into two branches, and we don't know these two current. Let me take this as current I2. Let me take this as current I1. Whatever the name you want, you can give. Either you can make this as I2 or this as I1. Not an issue. Okay. Then voltage is not given. Let us say there will be some circuit voltage. So we don't know that V. They are asking you to find the unknown branch currents. That is I1 and I2. This is the question. They give some 4 options also. Now to solve this, without a voltage we need to find a current. We know the resistance value and we know the total current, right? So for this we have a current division rule formula. That is, if you want to find the current I1, means that is the current in this branch, we can get a formula like this. I1 is equal to the total current in the circuit, that is 16 amperes. Total current, let me denote it as I, into see, if you want to find I1, this should be a total current into the resistance, opposite resistance of opposite branch. So we are finding I1, so opposite branch is this. So resistance of opposite branch, that is 8 ohms divided by summation of these two resistors, that is total resistance. 8 plus 12, that is 16 into 8 by 8 plus 12, that is 20. So this is how we should do it. So the formula is simple. Total current into opposite branch resistance by total resistance. So this is 20. You can say that 4 5s are 20, 4 4s are, then 8 4s are 32 by 5. If you simplify this, 5 1s are 5 6s are 30, it will be 20, so 5 4s are 6.4 amps. Let me take this as I1. So we got current in this branch as 6.4 amps. Now we can apply the same formula for I2. I2 equal to I into opposite branch, that is 12 by total resistance. That is the one method. Or you can also do it like this. We know that total current I is equal to I1 plus I2. So I will try to use this one. This is simple. So as we all know, I is 16 and I1 is already calculated. Therefore I2 will be equal to 16 minus 6.4, which is nothing but 9.6 amps. So select that option and just click answer for that. So option B will be the answer for this question. Okay. I hope you are following the point which I am explaining here. If this is clear, let us continue with the same kind of questions in next video. Okay. Now just want to have a request among you. If it is clear, you just mention it in a comment box and also share among your friends, sir. Thank you.